Okay. Our last sort of transformation is probably the most difficult one that we're going to do, and that is we're going to multiply by a number on the front. So if we think of y equals the absolute value of x, we're going to multiply by a number right here in the front. We're going to call that number an a. And a is kind of categorized in two ways. When the absolute value of a is greater than 1, meaning numbers like 2, 3, 4, 7/3, -7/3, -4. When you can take the absolute value of it and it's more than 1, it's going to do one thing. So let's take a look at that category of number first. So we're going to go back to our Desmos. We've got our absolute value graph. That's going to be our parent graph this time. And I want us to really focus in on, look at those three base points. 0, 0 is, we're going to loosely call that the vertex. And then we've got these two minor points that are at 1, 1 and -1, 1. So how do I get to these two minor points? If I start at 0, 0 and I go right 1 and up 1, I get to that point. Go back to the vertex. We're going to go left 1 and up 1, and we get to that secondary point from the vertex. Now, let's see what happens when we put a number in front. So let's add the number 3 in front of this graph and see what happens. So, okay, very different. So it got what we would think of as skinnier, which isn't quite right, but good enough. And is it going through that 0, 0 still? It is. It's going through that vertex 0, 0. But if we go right from that 0, 0 and up, we only go it. If we go up 1, we're not hitting the graph, are we? In fact, what are the places that it's going through when it's at 1? Well, if we start at 0, 0 and we go right 1, we have to go up 3 to get to the graph. Where did that 3 come from? That's the 3 we multiplied by. If we go back to that 0, 0 and go left 1, instead of going up 1, we have to go up 3 to get to that base point. So what happened here is it didn't make it skinnier. What it did was, imagine drawing this V on like a piece of rubber and then stretching it, right? We stretched these dots from at 1, we stretched them up to 3. And when you stretch something up, it looks like it's getting skinnier, but it's actually stretching vertically. So we call this a vertical stretch. And this is going to work no matter what kind of number we put on the front here. So what if I put on instead of so we're back to our parent graph, what if I multiplied by a 2? Well, from 0, 0, I'm going to go right 1 and up 2. Hey, look, there's the graph. Back to 0, 0, go left 1, up 2. Look, hey, there's the graph. So that's kind of how we know this is going on. Be wary of calling it slope, because it's not going to work exactly the same way after these 2 points for any other function, but it's a good way to think about where does that stretch happen. Now, we said it works for the absolute value of any number that's bigger than 1. So what happens if we don't put on a positive number, but we put on, say, a negative number? So let's put the number -2 on the front here. What happens? Well, now from 0, 0, we're going to go right 1, and instead of going up, we have to go down 2, which makes sense in my brain because positive is up and negative is down, right? So it's a stretch, but we've stretched it downwards instead of stretching it upwards, right? But notice we're always going from 0, 0, we're always going right 1 and then stretching. Go back to 0, 0, left 1, and then stretching. So this brings us to how we're going to write our notes about what's going on here. So when the absolute value of the number is bigger than 1, the graph stretches vertically. And since we are multiplying outside of the function, that makes sense. Everything outside makes things up and down happen. To do this stretch, we're going to do kind of what we were already talking about. You're going to start at the vertex. We're going to go right 1 and then up or down whatever that number A was. We're going to go back to the vertex. We're going to go left 1 and then up or down that A that we were looking at. What if we were using something like x cubed and we multiplied by a number on the front? This is a little bit trickier because what we're going to think of is that we're going to hold that origin fixed and we're going to stretch in either direction. So what happens if I put that number 3 right there? Now, see how it's not going through either of those points? But if I go to my origin and I go right 1, I have to go up 3 to get to that point where it's crossing the dot. And then if I go back to the origin and go left 1, because of its shape, I'm going to have to go down 3 to get to that spot where it's kind of at a perfect point. So you have to sort of think it through. Just remember, you're stretching by 3, but are we stretching up or are we stretching down? We need to sort of think that through. What happens when the absolute value of the number you're multiplying by is less than 1? So think of this as like 1/2 or 1/3, where the absolute value of your number is something less than 1. We put in a 1/2, a 1/3, a 1/4, a 2/3, negative 2/3, whatever we're doing, it's a less than 1 number. So let's go back to our graph in Desmos. So here is our absolute value bars, right? And let's put in a number that is less than 1. So let's put in just 1/2. And let's see what happens. Now, think about what we did before. From 0, 0, we're going to go right 1. And how high up do we have to go to get to our graph? Oh, look, 1/2. From 0, 0, we're going to go left 1 and go up 1/2. But does this look like it's been stretched anymore? This does not look like it's skinnier to me. This looks fatter. Why is it fatter? Okay, think of holding a pile of sand, right? If you squish down on that pile of sand, what happens to the sand? Well, it spreads out wide. So that's what we've done here, is we haven't stretched it, we've squished it or shrunk it. You can use the word squish, you can use the word shrunk. Mrs. Hoffman will understand. But anything that is an absolute value less than 1 will be a shrink. It'll squish it down so it'll look wider. That's the idea here. So when absolute value of A is less than 1, the graph shrinks vertically by that much. And we're going to, again, use the same pattern as before to achieve where those secondary base points go. This was probably a very difficult section to understand, so we'll do more examples as we go on, but very, very important topic within graphing by translation.